Hey everybody, this problem is similar to an SMO problem all the way back in 2010. It's an SMO Senior problem. It's similar, it's similar sort of structure, not exactly the same. But this is Senior 2010, and I think it's problem 4, I believe, 2010. Again, not identical, but similar. Now this is kind of weird because we are assuming that n is an integer. Now notice this couldn't possibly be true for all integers, right? Because sine theta and cosine theta are both bounded above by 1 and below by -1. So it's a special kind of n that would satisfy this. But of all the n that could satisfy both of these initial conditions, we're looking for the n such that cotangent squared is minimum, okay? And so the first part is fairly routine right here. This is the definition of cotangent, cosine over sine. We replace all this stuff with what it's equal to. Very, very simple so far. Now, the first big step, and it's not a surprising step, we're going to have to appeal to Pythagorean's identity, or it's very well known for all theta, all real numbers, that sine squared theta plus cos squared. This is just straight from the unit circle, okay? So, but this is a fact. And so this places restrictions on the n's that could possibly get the job done. Whoops, this is cosine squared. And again, it's no surprise when you see something. This is the Pythagorean identity. Okay, so we're just using that, and that's placing restrictions on the n that can actually lead to the conditions we're looking for. All right, and so the rest of this, I left out a little bit of the work, but n plus 12 quantity squared would be in the n plus 17 quantity squared would be in the denominator of both expressions. That's how it ends up over here when you multiply through. All right, and then when you expand everything out, everything's looking fairly routine. And we see the trick here. The Pythagorean triple kind of constituted this problem, so a lot of stuff cancels, and you're left with n squared. What do we got here? Plus 12n equals to 0. Okay, that's clear enough, right? The 289's cancel. 17 squared is 289. 8 squared, 64. 225 sums up. So that all works out cleanly, and it's designed that way, of course. All right, and now right here, this factors into n times n plus 12 equals to 0. And so that leads to two cases. N equals 0, of course. So let's see what happens here when we do n equals 0. For n equals 0, we would get, what is this, folks? 15 squared. 15 squared over 8 squared. Okay. Now, how about n equals to what? Negative 12? For n equals negative 12, what do we end up with? Let's see, if you put minus 12 right here, you get 3. So you get 3 minus 3 over 4 quantity squared. Right? Again, let's double check. If you put minus 12 right here, you get 3. If you put minus 12 right here, you get negative 4. So we have minus 3 over 4 quantity squared. And so certainly, what are we looking for? Are we looking for the minimum? Yeah, we're trying to find the minimum here. So the minimum would occur for n equals negative 12, and that minimum value would be equal to, what is that, 9 over 16? Yeah, 9 over 16. Okay. So that's the answer to the problem, folks. Now, again, it's a little bit of an odd problem. We're not trying to say that we're minimizing cotangent over all real numbers. We're just minimizing it over the type of integers that happen to satisfy these initial conditions. Well, we found out that there's only 2 of them. You know, right here we found out that n equals 0 or negative 12 are the only 2 integers that even meet the requirements. And this is a much bigger number. What is this? This is 225 over 64, right? 225 divided by 64. And the problem did call for the minimum value of cotangent. So that would be this 9 over 16 right here. So that is all, folks. I kind of liked it. It's kind of a weird problem in the sense that you're defining sine in a way. You're not defining sine, but you're restricting n, by using the fundamental identity of trigonometry. But in any event, I don't think I made any mistakes here. Let me know if you see anything wrong with this. And again, I think this was similar to number 4, all the way back SMO 2010. Okay, and there's your, just double checking, there's the minimum value. It's the min. Okay, thank you.